Hi guys, it's me again, Kimberly, the 100% unofficial Basherqueen, and welcome to part number 1 of my build series of my Strato 8S. I wanna try to fit the Max 6 speed controller, which is capable of 8S, into an armor chassis. And because it's much bigger, I think we have to make an adapter plate. And this adapter plate I will make from carbon fiber. So we have to make a drawing, we have to transfer the drawing into the computer, generate the tool paths, and then we want to cut it out of carbon fiber with a CNC router. Okay guys, here you can see this is a standard speed controller. The fan is broken, so I took the fan off. But this is a regular BLX 185 amp speed controller from the Armors, which is capable of 6S. But we want to go 8S, so we have to somehow bolt this in there. So first let's take out the original one. Okay, and as you can see, in principle there should be plenty of room to fit in this Hobbywing Max 6 speed controller, which is capable from 3 to 8S. So, but due to these upbent sides here, it's not even, so just putting double-sided tape underneath and put it in there will not hold up. And I don't like double-sided tape because I want to drive my Strato in the sand, and if sand comes between the chassis and the speed controller, it makes its way sooner or later all the way through this double-sided tape, and then the thing got loose. So I want to have it bolted in. And luckily these Hobbywing speed controllers, they already have these holes where you can hold the speed controller with. So I want to use these, and I can't just drill holes into the chassis because of this edge. And if we look at the original piece here from Armor, there are these standoffs, and this is exactly because of this. So it sits like this. So I think we have to make something like this, but suitable to run the Max 6, and I want to have it compatible to the old speed controller, so that we can run both setups, 6S and 8S, on this thing. Okay, let's get off the original one. So this is in here like this. Like this. And now the speed controller is not fitting on there. This is in our way, and besides that, it is just the wrong shape for it. So these mounting holes would be behind this piece here. So this is just not working. So let's make a new one. And I want to make the plate out of carbon fiber, because many other parts of the car will be carbon fiber, and for me carbon fiber looks best on these things. So, and I prepared already a little drawing. So I measured all the distances from these holes. I transferred them to a sheet of paper. Yeah, this quite chaotic drawing is the result of it. So here is where the servo post will be. Yeah, and I extended the shape so that the bigger speed controller will fit on it. And I have measured correctly, then this should go right on here. and this piece which holds the cable through the motor should be able to go here. Yeah, so, but let's try out. So I wanna transfer my drawing to the computer. Okay guys, now we are at my computer and I'm using Cut 2D Desktop for this, and this software is pretty much straightforward. It's easy to understand, and for small jobs like this it's absolutely enough. So first we set up the job. We've got a single-sided job. We've got workpiece size of about 130 millimeters times 80 millimeters. The plate later on will be 3 millimeters thick, and our 0 position for the Z axle is on the top of the material, and our X and Y 0 position is in the lower left corner. So that's okay. Now we've got an empty piece here, and I start with the guidelines. So I can do guidelines like this. So as I told you, I always do everything relatively to 2 and 2 millimeters. So, and then I've got my list of guidelines. So the next is at 6, then at 22. Now these are all the guidelines from the X axle, and now the guidelines from the Y axle. Okay, now that we've got the guidelines, let's start making the holes, and the holes are circles, and we have a radius of 3.2 millimeters. That's the diameter of my end mill. And we start in the front, and we have got a position of 6 and 17 for the first hole. And now we copy this thing, and we have at 12 our next hole, at 26, 12, which is here, and our next hole here is here. The holes for the speed controller for the Max 6, this is at 31, 41, 31 is here, 41 is here, and the other one is at 19 on the same axle, which is, I guess, here. So then the other holes for the speed controller are at 78. Which is here. And then the other one has to be over here. Okay, looks good. Then the holes to mount the original speed controller, 64 and 70, exactly here. And for the other hole is at 1270. It should be here. Then we've got the mounting holes for the switch, and this should be at 35.8. 0.25, so this is very odd, and the other hole for the switch is at 48 and at 9.5. So then we've got from where the part is getting screwed on the chassis is at 104 and 47. This is here, and at 83.564. This is this one. So I think these are all the holes, and now we make the profile of it, and I start here to here. Now we've got all the holes and the outer profile. I hope it's all good, looks good. And now we just make it a little bit nicer with this tool over here. We can round off all the edges a little bit. What it does, you can see here. It makes this edge just round. Next thing is that we make the tool passes. So this is based on the drawing, and we say the router, what the router has to do over there. So first, these outer holes, and say I want to have a drill here, and I want to have a cutting depth of in total 4 millimeters. My workpiece is only 3 millimeters, but if I set it to 3 millimeters and my zero from the Z-axis is not perfect, then sometimes the drilling is not going through, so I'm drilling a little bit further. So, and the tool that I'm using is a 3.2 millimeter end mill. This is this one. So at the end the holes will have a 3.2 millimeter diameter. So, and now the second step will be drilling all the other holes. Again, at the tool pass drilling, all the same. Perfect. And now to the profile itself. I select our profile vector and say I want to have a profile tool pass, and I want to have an outside one. So the end mill should run around my vector from the outside, so that everything what we see still on material will be there. So, and now we can go to our preview. First my outer drill. Okay, this will be all the holes. And now the profile. Now I can remove this part, and our final result should look like this. Okay, now I save the tool parts, and let's go to the CNC router and cut it out of a test material. Okay guys, now we transferred our drawing from the paper to the computer and saved the tool passes. And now we are going to our CNC router and make a test cut. I don't want to cut directly into the carbon fiber because this is all a test and this stuff is expensive. But I use this styrene, and this styrene is available in every hobby shop, and it's quite cheap. So I bolt the styrene, this goes over there. I bolt the styrene here on my MDF plate so that the pieces hold up pretty well, and then I start the software on my notebook. So that's the good thing of this MDF stuff. This is very cheap, and it's just hold on the aluminum bed from the CNC router, and if something goes wrong, you're cutting too deep or whatever, you're not ruining the bed from the machine, you're only cutting into the MDF. And as you can see here with other parts that I already made, this is why you always cut a little bit deeper than your material is, to make sure that you really cut through this. So now I've got my notebook over here, and the CNC controller software is running, and now I'm navigating with the cursor keys here the router to my 0th position. So when I turn it a little bit by hand, So now it's scratching a little bit on the surface. So now this is my 0 point from the Z axle, from the X and from the Y axle. Okay, now we can run the spindle and run the software. Okay, that looks good. And next is drilling all the holes. And here we go. Okay guys, that's it for the holes. Now I drive the router out of my way, clean it everything up and hold my piece with some screws also, that when it's getting finally cut out, that the piece also stays in place. So, and now I also turn on the vacuum. Usually I use a old dust shoe on this, but then you can't see anything. So and here we've got our piece. Okay, So in principle it fits. That is good. Okay, and because the speed controller is covering this hole here, we have to countersunk this one. Yeah, so far all holes line up pretty well. There's enough clearance to the diff housing, enough clearance to the pinion gear. Yeah, perfect. Okay. Yeah, now this material is really flexible. Later with the carbon fiber it will not flex anymore. Yeah, but here's enough clearance underneath. Good, very good. I think that can't be. Okay, let's disassemble it and cut it out from carbon fiber. Now doing carbon fiber we have to change our end mill. So this one is only good for wood and for soft plastic. And this one here is especially for carbon fiber. war laut. Beautiful. Yeah, I think this is a very good and clean solution. So guys, I'm pretty happy with the results. Now the speed controller is in place, the wiring looks good. So, and in the next video we build the differentials, and we build differentials from full hardened steel, which means hardened steel pinion and ring gear and internal, so that the whole thing can stand the 8S that we've got in our car. And guys, please give me notes down in the comment if you like this kind of video, what can I do better or slower or faster or whatever. So, because this is all experimental. Okay guys, that's it for this video. Thanks for watching. If you like this video, give it a thumbs up, subscribe, smash the bell button to stay notified, and see you in the next video. Bye!